So before starting, just to let you know that I have here the tab with the Hackfest with the Slack channel or the Hackfest channel in Slack. So if you have any questions, feel free to ask them there, or just interrupt me if something is not clear or whatever. Okay, so in this session, I will be explaining or introducing OSM primitives. And there are some interesting things that we should know about OSM primitives. So let's get started. I think you have already seen this picture in the introduction and yesterday in some session. And basically, the reality is messy and it's mixed. Telcos will always have history and won't change overnight. So OSM has to be able to be effective in the integration of a wide range of functions, different network functions. So in this picture, you can see PNFs, VNFs, KNFs, and there are a lot of network functions, and each one has some characteristics that are different between each other. And basically, in order to operate and perform actions in these different network functions, we need to get or to do different approaches. And OSM creates the space for that integration work to exist. So the VNFd that I think you are already familiar with that term. The VNFd is basically metadata, charms, and integration. So the metadata basically is declarative YAML in which you explain or you describe the number of BDUs, for example, of that VNF, the connection points each BDU has, and so on and so forth, the flavor and those kind of things. But there's also some operations code that are called charms that basically handle the install, update, configure, integration between applications in the VNFd. So is this part in which we are going to focus on today's sessions. Charms also provide a set of scripts for everyday operations like backup, restore, health check, reset, and so on. And these are called charm actions, and in OSM are called primitives, but those are basically the same. The VNFd decides which charm actions are surfaced or exposed in the UI as OSM primitives. And also you can set default parameters for the actions in this context. So the summary until now is that OSM primitives are mapped to charm actions, and now we'll see different, let's say, kind of charms. So we have OSM, okay, and we also have the workload deployed. That workload can be on cakes, on a machine, virtual machine, PNF, or whatever workload, it doesn't matter. So to operate that workload, to perform actions or configure that workload, we don't want to hard code anything in OSM. So the code for operating should be in another place. This place is the VNFd, and it has to go into what we are going to call operator instance. So in this picture or in this slide, we are basically showing an example of a workload that cannot be, let's say, modified. For example, a great example of this is a VNF. Imagine you have a physical appliance, a router that you can and that you want to operate, but you cannot install software there to be able to perform actions. So that code should be outside of the workload, and that's what we call proxy charms. And these proxy charms right now can be deployed in both LXD and Kubernetes clouds in OSM. Okay, so in this case, OSM will perform actions to the or execute or invoke actions in the proxy charm, and the proxy charm, that's basically Python code that will perform the action to the workload via SSH, REST API, or whatever. That depends on the nature of the workload. And there's another another example of kind of workloads that are basically or can be modified. Let's say one workload that is a VM that is based on Ubuntu, and we can install software there, and we can perform the operations from inside the workload. So in that case, this operations code will go directly to the or will be installed or will live in the same place as the workload. Okay. So integrations or the VNFD, sorry, describes lines of integration between different applications. So in the VNFD, you can have multiple VDUs, and each VDU has one chart. Yeah, sorry. Anyone wants to say something? Okay. So I will continue. You can stop me whenever you want. Okay, so the VNFD shows lines of integrations, as I was saying, and basically you can have one VNF with two VDUs. Each one can be managed by a native charm, for example, and you can integrate those using or in the VNFD using relations, and that's something that we will be showing afterwards. Okay, so now we will zoom in a bit and see how the relations or the integration works with using charms. So this is a charm, and basically a list of integration points. So for example, this charm has an endpoint that says I can use a MySQL database, or I can send my logs to a syslog, or for instance, I can use LDAP. So there's another charm, for example, that can provide LDAP. So those two are two endpoints, two integration points that have the LDAP type. So the type is the same. So matching, this means that matching integration endpoints can be related, and that's what's basically a relation that allows different applications to integrate between each other, and yeah, well, basically that. And yeah, so if we take this concept further, we can build complex compositions by integrating different charm applications, like so. Okay, and if we can see some real examples of complex applications built with charms, and a complex integration example is, for example, Hadoop. Each one of these charms will have scripts to handle the life cycle of the particular application, scripts that handle configuration changes, scripts that handle integration when another application is related, and so on, and scripts that handle actions or OSM primitives. Okay. So any operation that can be a script running as root can be an action, and all actions are custom to a particular charm. These lists are basically just examples, but is free to the developer of the charm to include as many actions or as many custom actions as he wants. So this backup, monitor, debug, add user, and so on are just examples. And each primitive is a charm action script that takes basically parameters and produces an output. For example, in the case of the backup, the script will be the code to perform the backup, for example, in a database or whatever, and basically as parameters we can think about the output or the destination of the where we want to the backup to be stored, for example, and the output is the execution of that action. So now we can zoom in, zoom out and see all different scripts that compose a charm. So first of all, we have life cycle scripts that handle the install, config, update, remove, and scale events. We also have integration scripts to handle, for example, the relation when the MySQL database has been related to my charm, or the LDAP charm has been related, or whatever. And also a script for each individual action that my charm supports. Okay, so for example, the charm, inside the charm, there's a metadata file, and that is called actions.yaml, and basically this describes a high level, it shows a high level description of the list of actions that are supported by the charm, a description of what that action basically does, and the parameters that it needs, and so on. The actions are usually implemented in Python or in Bash. So this is, for example, one example of an action implemented in Bash. It can be useful for very simple cases, but we always, most of the times, we recommend to implement them in Python using the new operator framework. We are basically using that for all the examples in the Hackfest. Okay, now we are going to show some components of OSM, and we are going to explain what's the Juju controller, or introduction to DCA. DCA and Juju controller is the same, and it's a core component of OSM that handles the operation packages, the charms. So this part of the session will help you understand a bit how is everything working in OSM, so that the charms can work fine. So these are just some components. The user interface, for example, talks to the northbound interface, the NPI, and there's a manager that manages the life cycle of the OSM deployments. This manager is the LCM, and for example, when we deploy a network service that is composed by two VMs, for example, the resource orchestrator, the RO, will instantiate the VMs in the VIM, taking into account the metadata, the declarative part in the VNFd and the network service descriptors. And the VCA, that is the component we are explaining here, will be in charge of deploying the charms and to configure the workloads, let's say day 2 operations. So for the operations and day 1, day 2 actions in the workloads, the VCA, the Juju controller, is responsible for that part. Okay, just as a quick summary, basically Juju drives application operations on both machine and Kubernetes substrates. So basically, Juju allow the installation of different applications in different substrates, and there's some list of substrates that are currently supported by Juju, and basically it allows to easily install, update, configure, scale, and integrate. That's very important, and execute actions in those applications. So in general, this is how Juju works. There's a Juju client that basically can be installed in your laptop that talks to a Juju controller that is like the brain. The Juju controller has different models for different scenarios, and this model that we are showing in the slide is a charmed Kubernetes. So Kubernetes deployed using charms, and we can see the different components of Kubernetes there, integrated one with another, and so on. So basically, Juju helps you model the application, and each one of these applications is a charm that has inside the Juju agent that listens to the change in the model. So it reacts to events in the configuration, it reacts to events when one charm is related to another, and so on. And basically the charm performs actions and operations in the workload. So in OSM, basically the Juju client is the LCM. The LCM talks to the VCA, and basically that's the workflow. So the LCM executes actions talking to the VCA, and the actions are performed in the workload. It's worth mentioning also that one Juju controller can handle multiple models of different applications, and even cross-model relate applications between different models. So we can have different models and relate or allow the integration between one application that lives in one model and one application that lives in another model. The VCA also uses different models for different network service deployments. So imagine you have one network service deployment that is only for Kubernetes, so only KNFs. So the VCA will create one model that is in Kubernetes and will deploy the charms there. And for example, another one with only VNFs, there's a model that will have all the charms with for the VNF workloads. Also, in release 8, we have included this new feature in N2VC. So basically, the Juju client, that is the LCM, now can talk to an HA Juju controller, so that can scale, and it's a production readiness feature that we, or related feature that we added in release 8. So basically, as a summary, the VCA coordinates all OSM primitives. And for example, I'm going to put here some examples so you can understand a bit better how this works. So the in terms of the configuration, for example, one charm can have different configuration parameters, and basically the LCM will tell the VCA to deploy the charm and to include that configuration. So for example, the CA certificate, the HTTPS proxy, and so on. And the charm will perform the action, the operation to make that thing happen. Also, for the actions, the VCA will perform the action, for example, to do a backup. Also, for the integration, will tell the charms to integrate, and yeah, basically that's this is the end of this first session. So as a summary, we started the session saying that there are different network functions. PNFs, for example, those cannot be modified. Those are physical appliances that you cannot install anything there. So for that, we have proxy charms that are operation code that lives somewhere else. In this case, in LexD cloud, and OSM will talk to the operational code to the charm to perform actions in the PNF. And there are also some. There can be also some network functions in the VIN, so VNFs, and some of the VNFs could be modified, and we can use native charms, so the operations code can go right inside the VNF, or in some other cases we may not be able to modify the VNF. So in that case, we will also use proxy charms for operating that workload, and same thing for KNFs.
I have adopted the native charms are deployed as a VNF, as part of the VNF, or I don't understand exactly.
Yeah.
Where are they deployed?
Okay, so think first of all, think about the charm as code. It's just Python code with scripts that each script does something to the workload. Okay, so if you deploy, so in the case of native charms, the arrow, that is the resource orchestrator, will spin up a VM into the Vim, into the OpenStack, for example. And then the charm will be installed there in the same VM. Okay, so basically the code will be in the same place as the workload. I don't know if I explain myself.
So yeah, I think so. It's like you deploy a new VM that executes all the code, all the Python code. I mean, that's right. Can you hear me?
I can't hear
David, it seems like we can't hear you.
Yeah.
Okay, it seems like he has to reconnect. Can you restate the question? Maybe I can help you. Anna?
My question was that the Python code is installed or executed in a VM inside the VIM where the VNFs is deployed. I mean,
Exactly.
sorry.
Yes,
Oh,
exactly.
yeah.
It's the VNF and the Python code are living exactly in the same VM. So in the case of a native charm, you are deploying the VNF directly with the charm, and the Python code is in the same VM. You got it right.
Okay. Okay, and that VM is managed from OSM without no need of proxy charms and directly from OSM.
The VM is managed by OSM. It's instantiated with OSM, and Juju afterwards installs the charm software on top of that charm software and the VNF on top of that VM. But the VM is deployed with OSM, and OSM is always aware of it.
So all the speed of the deployment and that kind of things will be improved. I mean, for example, when you're trying to use in a production environment. Yeah?
Sorry. I had to restart. I had some problems with my internet and I lost the last 1 minute, I think. Could you repeat?
I was handling the question, David. No worries. If you want, you can concentrate on fixing the presentation again, and I can answer in the meanwhile. So you were talking about performance, Anna. Yes, the thing is with LXD proxy charms, it's a little bit slower. Native charms might be a little faster, but if you want to improve performance, there's another way of doing it in proxy charms, which is deploying them on Kubernetes, which is a new feature. I think at some point we will talk about it also. So yeah, there are different ways of improving performance for charm deployments if you are talking about that.
Okay. So I'll ask you later. Thank you very much.
No problem.
Just one question regarding VCA. How would we like I have understood models, I have understood controller, I think, but VCA would just be a collection of controller plus models, right? Or is it beyond that?
Yes, it's more or less of a kind of abstract concept, which is a definition of all those parts, which basically the components which are managing an operations in OSM. We are englobing them in VCA with that term. But yes, you got it right. It's basically all those concepts combined. David, correct me if I'm wrong. We still can't see any presentation if you're trying to present or anything. David?
Yeah, sorry. It's a bit slow when activating the microphone. Sorry. Yeah, I'm preparing the next presentation. Yeah.
Okay, I think the one that asked the question was Nishank. Did I answer your question more or less?
Yes, you were. Thank you.
No problem. If anyone else has a question, go ahead while David is fixing the presentation.
Yeah, this is Shweta. I have a question.
So like OSM-MR and OpenStack, we have some IPs here on which it is installed, and then when we deploy a VM or a VNF in the OpenStack, then a IP series of 198 or 192 is there. So when you deploy the charms, then is the connectivity between OSM-MR and the instance launched in OpenStack required for the charms to work?
Yes, that's always required. So, well, I mean, usually if you are deploying something with OSM in an OpenStack, by default, you should have connectivity because you have to somehow communicate to the OpenStack. But yes, usually also the OSM should have also access to the VM, at least for the charms to contact. But the VM doesn't need to have access to the charms. It's only one of the ways. Correct me if I'm wrong.
Okay, but I tried just now, and even when I was doing it on our own company server also. So these instances which are launched, I cannot ping even in this, such servers which are provided in the lab now. So what is that network connectivity which is required so that charms work? I mean, that is a little confusing when we were trying for the charms. So now also I tried to ping based on the topology I have in my OpenStack. So I was trying to ping the server of a VNF from OSM-MR and OSM-MR to this Magma A gateway, but I'm not able to.
Well, we aren't yet in the practical part of this. If you want to expand this, maybe you can talk to me about in Slack and I can fix it for you, but maybe it's better if we go forward with the presentation.
Okay. Okay, fine. Yeah, we can do it when we do hands-on. Yeah.
Exactly, yes. Or talk to me in Slack directly and we don't distract you anymore.
Okay.